good. So in something called apps, so let me get out of there. In something called apps, APPS, there is something called polynomial. Let me see, just 1 second. Yes, that is the one, number 9. Okay, so at this stage in calculus, I don't expect you to do or apply the quadratic formula for every little thing. So we do have now a calculator that allows us to find polynomial roots. Okay, so we press enter. The order of the polynomial, I don't know why they say order, it's degree, but in the calculator word, it's called order. So it is 2. So I'm not sure how you do this on your calculators. I mean, I can look at my calculator, but with the software, I have to press on graph. And it allows me to enter the coefficients. Okay, now there is a problem with doing this because I will not get an exact number. It will give us approximations. So I may still, in this case, still have to show you with the quadratic formula. But let's do this first so you can see where it is. So 5 and enter. The next one is -6 and enter. Doesn't take it. Careful how you do this because, okay. So that is, okay, -7. And enter. So you see the equation, make sure that this is correct, 5x squared. Oh, we don't have b, of course. X or b, it doesn't matter. I'm getting the solutions. -6 and minus, it's -27. Okay, and then you can click on graph again. Again, this is the software, so I'm not sure, make sure that that's the case. Or solve. I don't know exactly. I don't think the enter will give me the answer. I think I have to. So it gives me x1 -1.8 and x2 equals 3. Okay, so good. So I don't have to do the graphing, the quadratic formula because the answers are nice. I was expecting like -1.39562 and so on and so forth. So then B1, the first B, is -1.3, and as expected, the second B is 3. Otherwise, I would have been in big trouble. Okay, so I'm going to stop my recording. Where is my recording? Here. Stop recording. Okay, I'm going to post that. I'm also going to stop sharing. Okay. So we determined B1 to be -1.3. Then I go back here to determine the corresponding A. So A, obviously as expected, A1 will be 3 minus 1.3. So it will be 4.3. And obviously as expected, our 8.
-1.8 for B1.
Oh, it was 8? Sorry. Yes, you're right. I don't know why I wrote. Yes, thank you. I wasn't trying to see if anyone is watching. No. My mistake. Sorry about that. So, of course, 3 minus 3 is 0. So we know the points. So this point, 0, 3 as expected, which we knew from the get-go. And the other point is 4.8 for x, -1.8 for y, right here. 4.8, -1.8. I'm going to write them again. So that was page 4. So the 2 points. I'm going to call this point uppercase A and this point uppercase B, so we know what they are. So uppercase A, as expected, 0, 3. Uppercase B, what was it? 4.8, -1.8. Okay, so after all this work, they're asking us to determine the equation of this, which I know already. This is y = 3, no discussion there. And now for this one, we only need to determine the slope. I just need to plug in the numbers here to find the slope. So we have y minus 3, finding the slope in here with a and b. This is a, this is b. Negative a over 4b. So negative a, I'm going to write it here, over 4 times negative 1.8. So you can see it. And then x minus 12. Okay. So again, the slope was, let me also put it again here. Where was my slope? Negative a over 4b. So negative a over 4 times b, which is this. Okay, can I simplify? I can simplify. So then y minus 3 equals, there are two negatives. I'm going to also multiply by 10. So 12 over 18, x minus 12. I will simplify by 6. And then I have y minus 3 equals 2/3 x minus 12. Finally, 2/3 x minus, I'll simplify, minus 8 plus 3. Could we have chosen, I'm kidding, could we have chosen a longer problem? I'm kidding, it was a very good problem. So the equations of the two tangents are y equals 3 and y equals 2/3 x minus 5. Look, 4 pages later. I'm kidding. So y equals 3, and this one is y equals 2/3 x minus 5. Very good question. Thank you. Anything else? Did we work on anything else? Other questions for me? Other questions? Okay, in that case, but you can always stop me if you have anything. In that case, we'll continue with 3.6. On page 5. So log functions and inverse trig functions. Then with 3.10, you can say, why are you jumping? Because it's together with all the other functions. 3.10 deals with hyperbolic functions. So that's the plan for today. That's my target, we hope, to accomplish at least today. Okay, so let's start with the log functions. So when we differentiate natural log x, we do get 1 over x. Now, what if I have natural log of a function prime? Can anyone suggest, recommend? Anyone has any idea? A wild guess.
1 over a.
But remember, there is something very important that we always, always have to say in our head.
Times f prime.
Times f prime. Good, awesome. Always. Now here I should have said times the inner function prime. Why didn't I say that? But it's there. Why didn't I say that?
Because it's 1.
Because it's 1, awesome. Now before we move on to examples and practice this, I'd like to look at the natural log of the absolute value of x. So this is what I would like to discuss for a few minutes. So this is a function which is natural log, applied to the absolute value. So we always start with the absolute value. Can anyone refresh our memory on the absolute value? What does it equal to? What is the formal definition of the absolute value? Anyone?
If x is equal to, if x is greater than or equal to 0.
Excellent. And the other one, the negative. Excellent.
Yeah.
Perfect. So then this function now, natural log of the absolute value of x, because the absolute value of x has two options, then the natural log of the absolute value of x will have two options. What will the options be?
If ln is...
No, we have to write natural log of
x.
if x is
If x is greater than 0.
exactly. Thank you so much. Because we cannot plug in 0 in natural log. Here, equal symbol is correct. But here, equal symbol will be incorrect because we cannot plug in natural log 0. Here's the graph of natural log. We know that. That's why we always go back to graphs, because it's so easy to remember. I cannot plug in 0 in natural log. Good, awesome. What is the other option?
Negative and natural log of x. Oh, negative x. Less than 0.
Good, of course, that's it. So if this inside has two options, then the function has two options. It has the first option when x is greater than 0, and it has the second option when x is less than 0. Now let's differentiate. Let's differentiate the absolute value of x. If I differentiate this, I have to differentiate these two. One for x greater than 0 and the other one for x less than 0. So let's differentiate this and put the answer here, and let's differentiate this and put the answer here. We just looked at natural log x prime. What do I write?
One over x.
Excellent. So now what about here? But remember, now I have to use this. How come? Because this piece is not plain x anymore. How do I write it?
Negative 1 over x.
So I have to write 1 over the function. What is the function?
The x.
What is the function? We are differentiating this. What is the function?
The natural log of negative x.
So
Negative x.
negative x is the function times,
1.
careful, times the inner function prime. We have to get used to say that in our heads. Times the inner function prime. What is the inner function prime equal to?
Negative 1.
Negative 1. Awesome. But when I simplify this, what do I get from this product?
1 over x.
Exactly. So I don't need any of this because they are the same. So from here, I will write, and this has to be carved in stone. We have other things that we carved in stone already, like, I'll refresh your memory in a minute. So the absolute value of, the natural log of the absolute value of x prime is 1 over x. The only restriction is x cannot be 0. Why? It turns out that this is still 1 over x. When you multiply these two, you still get 1 over x. And this is a very important result. For chapter 5, please carve it in stone somewhere. What are the things we carved in stone? Many. We carved in stone that 1 over x prime is negative 1 over x squared. We carved in stone that the square root of x prime is 1 over 2 the square root of x, and the sine and cosine. And we carved in stone a lot of things. So this is one more that we have to, sorry about that. This is another one that we have. Let me turn this off. What is going on? Sorry about that. It's completely off right now. Okay, so this is another thing that we carved in stone. Natural log of the absolute value of x is 1 over x. And you will see why I need this result for chapter 5. Crucial result. Okay, so now let's open the floor for discussion and picking some whatever you want. Where is my book? My book is here. My 3.6. Where is my 3.6? .6. Okay, so let's choose a couple of problems to work on from